Your lesson on linear programming. In this video, we will look at applied mathematics in action. Specifically, we will go over the entire formative assessment on linear programming, and we will also have you try problems just like it so that you can better develop your skills. Let's get into it. So first, looking at your formative assessment problem, let's introduce it again. We had a situation where we had different physical activities and the calories burned per hour depending on weight. And 3 students were compared. They were doing different activities, and based on this table we got all the data we needed for the problem. Let's get into it. So the 3 students in the formative assessment were Georg, Letitia, and Bruno, and it gives you some information about all of them. However, like with any criterion D task, there's essentially one problem to be answered. Even though there's many things to read and consider and lots of calculations to do, all those calculations lead to one question to be answered. And in this problem, it was this. We want to find the least amount of total hours that Bruno, this student here, needs to spend exercising in order to meet his competitive goals. So again, what is our goal? To find the least total amount of hours he needs to work. But what do we know about Bruno? We know he does the same activities as Letitia. So that tells us, okay, we need to figure out what activities she's doing, and it doesn't tell us here, so we'll have to do some calculating to figure out her activities. What else do we know about Bruno? He wants to burn more calories on Saturday than the other 2 students. He also wants to burn more calories on Sunday than the other 2 students. So in other words, in order to solve for Bruno's activities and hours, we also need to know how many calories Georg and Letitia burn on each day. So by reading about Bruno, we're figuring out the information we'll need to find out about Georg and Letitia that's going to help us answer this question about Bruno. What else? He wants to burn more calories than Georg and Letitia combined. So again, we need to know how many calories they are each burning on Saturday and Sunday in order to answer the question about Bruno. All right, so let's get started. First student is Georg. We are told he's 72 kilograms and he is playing volleyball and cycling. So it also tells us he can spend a maximum of 7 hours in total on these 2 activities. So we were told that X represents his hours of volleyball and Y his hours of cycling. So his total hours must be 7 hours. He can spend a maximum of 7 hours. That means he cannot spend more than 7. So his volleyball hours plus his cycling hours are less than or equal to 7. That's our first inequality we can write. Next, so there's that equation there, or inequality. Next, we are told his goal is to burn 3,000 or more calories. So how does he burn calories? By playing volleyball and by cycling. So here is that inequality. Here is volleyball hours, cycling hours, and we want the calories to be greater than 3,000. But where did these 2 numbers come from? Well, let's look at the table. Okay, he is 72 kilograms, so we're looking at this last column here because this is 70 to 80 kilograms. And we know he does volleyball for his Saturday activity where he's burning lots of calories. Okay, so he burns 720 calories per hour. So 720 calories per hour spent on volleyball. Now his other activity is cycling. So we look at cycling, and that is a 327 calorie per hour activity. So here's 327 calories per hour of cycling, and so this gives total calories, and that must exceed 3,000. All right, so those are 2 inequalities we can create for him, but there's another one. It also says that his volleyball hours cannot exceed 5 hours and his cycling hours cannot exceed 3. So that is this last set of inequalities here. His volleyball hours are less than or equal to 5 hours, and his cycling are less than or equal to 3. So now we have 4 inequalities, which will help us graph the feasible region for Georg. First, we can also simplify the two inequalities here into an easier form to graph. So here we have x plus y is less than 7 or equal to 7. We can turn that into this by moving the x over to this side. The other one here, we can move the x value over here and then divide everything by 327 to get this inequality. Now let's graph all those. Here's the 4 inequalities. Here's the graph. Check your work. Make all the corrections you need to on your formative assessment. So pause this video if you need to. Okay? Here's X, volleyball hours. Here's Y, cycling hours. And you can see everything's graphed on here. Here is the line, dotted line for, that's this one here. Yes, that is the calories, okay? So there's that line there. Here's the one for hours. And then here's the 5-hour limit on volleyball, and here's the 3-hour limit on cycling. The zone that's shaded is here because we need to burn greater than this dashed line, that's greater above that one for calories, below this one for total hours, less than this one for that, and less than this one for this. There's our feasible region. Okay, the next step is to find the optimal solution. So Georg is trying to be efficient with the time spent on his activities. He wants to spend the least amount of time but burn the most calories. So that is this point here. Okay, that's 5 hours of volleyball, 2 hours of cycling, and you can see here 5 and 2. The calories burned are 5 times 720 and 2 times 327, 4,254 calories burned in total. And that meets his 5-hour requirement here. It's under the 3-hour requirement here. In total, it meets the 7-hour requirement he has, and it meets the requirement of surpassing here 3,000 calories. It's actually more calories, right? Okay, there's the answer for Georg. I saw a lot of success on your assessments with that, but double check everything, make sure everything's perfect. Now, try another one. So grabbing the new page that's been given to you, you're going to try a similar problem, new students, new data. Here's the situation, read it carefully. We have Urosh, Arena, and Real Yeah. And basically, let's begin with Urosh. Read that, use the table, solve, and answer the question, what is the optimal amount of time Urosh spends on his two activities, which are basketball and table tennis? All right, check your work here. Here are the 4 inequalities. Graph, they look like this. The feasible region is this zone right in here. And there are 2 possible optimal solutions. This one here, this one here. This is the better of the 2, as it is more hours of basketball, which is a high calorie burning activity. So 7 hours of basketball, 1 hour of table tennis, and here is the total calories burned doing that. Awesome. Let's go back to the formative, check our work. Things got a little tougher when we looked at Letitia on the formative, and more students struggled there. So let's take a look. Here's Letitia's information. We were given her Sunday calorie burning graph right here. So notice this graph now is hours versus calories burned. This is not the same as going back to here. It's not the same graph here, right? This one had hours of one activity on one axis, hours of another activity on the other axis. That's not what we're seeing here for Letitia. This is hours spent, calories burned. So if you follow this line, it shows as she spends more hours on whatever activity this is, we don't know what it is, more hours, the calories burned are going up, right? So the slope of that line can tell us how many calories she's burning per hour. Okay, and remember, for Bruno, the final student, the one we're trying to answer the question about, we were told that he participates in the same activities as Letitia. So we're looking at Letitia, we got to figure out what activities is she doing. Okay, well, let's look at this line first. Okay, so her calorie burning graph is here. Calories, hours. Okay, let's figure it out. So I'm going to do like a slope triangle. I'm going to go from here to here, and I'm going to go up to here. So I'm trying to see what is the rise and what is the run of this line. Because if I get the slope of this line, those are my calories burned per hour. Okay, so this goes up about 1,500. I know it's not precise, it's just a little bit under, but approximately 1,500 calories. And here we have 5 hours. So to get the slope, approximately 1,500 divided by 5, rise over run. That works out to 300 calories per hour. So I look at my table, and Letitia is 52 kilograms, so I go to under 60 here, and I'm looking for about 300. I'm going down, oh look, 292 here, 295. So I did see a lot of students answer dancing because they said about 295. However, I am personally a skateboarder, so I think it can be either one of those two. Both of those are close to 300. I'm going to go skateboarding. Okay, 292 calories skateboarding. Great, that's one of her activities. But what is her other activity? This is her Sunday activity, the low calorie burning activity, or medium. Let's figure out her other one. It says her calorie burning equation for Saturday, for her Saturday activity is given here. So I'm going to take that equation and I'm going to rearrange it, because if I can rearrange this to y equals mx plus b form, then I can figure out the rate of her Saturday activity. So let's take a look. I moved this 1785 over here. Now I'm going to divide everything by 3, and I get this equation. All right, in this equation, we clearly have a slope here of 595. And again, just like this one, the slope represented the activity, or sorry, the calories burned per hour, right? So this represents calories burned per hour as well. Okay, so I'm looking at the table again for Letitia, under 52 kilograms, and I'm looking for 595. There it is. There's her high calorie burning activity, 595, right there. Martial arts. That's her Saturday activity, martial arts. Okay, so now we know she's skateboarding on Sunday, martial arts on Saturday. And how do you graph this line? Because not only do we need to know what activities she's doing, because the same ones, Bruno will do the same ones, but we also need to know her calories, because Bruno, as we know, also wants to burn more calories than Letitia and Georg. So how many calories is she burning? Well, her one goal was to spend the same amount of time on each activity, given that the amount of time spent leads to the same number of calories burned. Now this got a little confusing, so look at what happened here. Here's the graph. I've changed the graph by adding this equation, the one we just took here and rearranged, her Saturday activity. I graphed it here, and of course negative 1400, our y-intercept, is off the bottom of the graph, so it's kind of hard to graph it, but we can simply put in some values of x in here, like x equals 3, x equals 6, whatever we want, and we can calculate the y, and by getting those coordinates we can plot 2 points and then connect them to make a line. So here's the line for her martial arts activity. Make sure you add that correctly to your formative and you understand how to graph it. Now again, her goal was to spend the same amount of time on each activity and burn the same amount of calories. Now here's the strange thing about the Saturday line. It does not begin at 0. It begins here. It actually begins below. So that's strange, because it makes sense when you do 0 hours of something, you burn 0 calories, and then 1 hour of something, you burn some calories, and 2 hours, you burn more. But what's going on here? Here's several hours pass, 2 and a bit hours pass before she starts to actually burn calories here, which is strange, but I want you to interpret it this way. That means this activity, which is her martial arts, maybe she goes there and she receives some lecture or some, there is some instruction about martial arts where she's seated maybe and not burning any calories. She's just receiving instruction, and then that's about 2 hours of instruction, and then she becomes active. She starts to actually participate, and then her calories start to burn. So that's one way to explain this weird graph here. Now, where is the point where she meets her goal, where she's spending the same hours and same calories? Well, that is the point of intersection of the two activities, right? Because that point represents the point at which the same hours lead to the same calories. So you're looking for the point of intersection. You can estimate that off the graph, but to be more accurate, we should take the two equations and set them equal to each other. So here is her Saturday activity, martial arts. Here's the equation for the blue line that we had at first. We weren't given that equation, but we can write an equation. I assume this is skateboarding, so the equation is 292x, because that's a slope of 292, and it begins at 0, so y-intercept of 0. So there's my two equations. Now I set them equal to each other in order to find the point of intersection, because that's where the two lines are equal. Solving this, I subtracted 292x from here, and moved the 1400 to this side, divide by 303, and I get 4.62 hours. This is 4.62 hours, and that's when you spend the same amount on both activities. See, you can see they both have 4.62 there, and they both at that point, if you plug in 4.62 into one of the equations, you can also solve how many calories that is, and it looks like 1,349, that's what we get. So that's the point at which both activities, same hours spent, same calories burned. All right, so now we have everything we need from Letitia. We can continue to Bruno, but first, you're gonna go back to your new problem that you're trying, and you're going to solve for Arena. So read her information here, figure out what activities is she doing, and where is that point of intersection, the point where she's spending the same time and getting the same same calories. All right, let's see what you solved. You should have found this blue line here, which has this equation, or this one here when you simplify it. Okay, oh no, sorry, that was given to you. Change it to that. Here's the equation for the other one. What activities are those? Well, we can see she had a weight of over 70, and we see 899 here as a slope of this high calorie burning activity. 899 is here, so running is her Saturday activity. She's burning a lot of calories. And looking at the other equation, which I got from looking at this line and getting the slope of that, the slope is about 572, and that is this activity here, swimming. So her two activities are swimming and running. Okay, swimming and running, or running and swimming if you're talking about Saturday and Sunday. Now, those are the two activities. How many calories? Well, the point of intersection of these two lines is here, 3.3 hours on each, and the calories burned here are 1924. So I hope you got that solution. All right, going back to the formative, let's look at Bruno. Let's wrap things up. Bruno, as we know, same activities as Letitia, which are skateboarding and martial arts. And Bruno wants to burn more calories on Saturday than whoever had the most. Okay? More calories on Sunday than whoever had the most as well. But let's look at Saturday first. Georg had 5 hours of volleyball times 720 calories. Georg burns this much on Saturday. Letitia had 4.62 hours of martial arts, burning 1,349. So Georg's goal is Bruno's goal is to surpass that. He is very competitive. He wants to burn more calories than that. So looking at Bruno, who's 61 kilograms, that's going to be right here, and doing martial arts on Saturday, 709 calories. So one inequality for Bruno is 709 calories. That's for martial arts, times the amount of hours he spends on that, has to be greater than this total that Georg had. Again, he has to exceed whoever had the most, which is Georg. Okay, now let's look at Sunday. Sunday's goal for him is also to surpass whoever had the most. On Sunday, Georg is doing 2 hours of cycling, times that calories, 654. Letitia is doing 4.62 of skateboarding. Now remember, Letitia had the same hours, same calories. You can see it here. Now, who's doing more? Letitia. So Bruno's goal is beat Letitia, burn more than that. His activity is the same as Letitia on Sunday, it's skateboarding. So let's find skateboarding for Bruno right here, 352. So 352 times his hours on Sunday must exceed whoever had the most on Sunday right here. That's the second inequality. Now we need the third inequality for Bruno. His other goal is to surpass both of them on the weekend. So whatever their total on the weekend is, he wants to do more than that. So here is his two activities together, his 709 plus that, and that must exceed the total that they burn all weekend, which is all these numbers here added up, their total for the weekend. There's the third inequality. So now to graph those, to get Bruno's feasible region, Here's the Saturday one, simplified to this. Here's the Sunday one, simplified to that. And the total, weekend total, simplifies to this equation. Check the work. It's just rearranging, solving for y. Graphing those three, we get this. The feasible region now is not within, it's actually out here beyond, because he's trying to surpass the total, so out here. But he has limitations. He wants to do it in the least amount of hours. So he could do exercise anywhere out here. He could do like 15 hours of one and 9 hours of another. That would be somewhere here. And of course he'll beat them. He'll beat how many hours? Because he can do unlimited hours. But his goal was not just to beat them, but to beat them efficiently. Spending the least number of hours, he wanted to exceed their calories. So the least would be along this line here. Here we can see 5 hours and almost 10 hours. Here we can see 7.9 and 3.8. So we went with, or I went with, this point here, because this one represents, if you round up, 8 hours of martial arts, 4 hours of cycling. Was it cycling? No, skateboarding, sorry. And that's lower than 5 and 10. That makes 15 total. This makes 14 total. Or sorry, 12 total here. So you can see, we assume that we have a whole number of hours. This point is close to 8.4, which would be here. And, 8.4 would be right here. And that's the least amount of hours he can spend, 12 hours. So he spends 8 hours on martial arts, 4 on skateboarding. We have the calculations here. 8 hours of that exceeds his goal of beating whoever had the most on that day. 4 hours of skateboarding, here that number exceeds this, which was the highest number on Sunday. And the total, his 8 and 4, that number exceeds their total. So he's met all the goals and he's done it in the least number of hours possible, 12 hours. Okay, that's the answer to the whole problem. A criterion D is not done to away with the answer. That's the answer. Bruno spends 12 hours and he beats his competitors, his friends, on the calories burned for the weekend. So try your problem, finish it up, and here we go. Here's Realia, and the answer is, do I have the graph? Here's Realia's graph. Yeah, let's see. Oh yeah, here's making the inequalities, so check your work carefully here. Okay, checking all the work here. Here's him beating Saturday activity. Here's him exceeding the Sunday activity, total calories, and here's the weekend total. So check your work carefully. And here's the graph. You can see his goal, least amount of hours. Okay, here's about 6 and 10 if you round up, so 16 hours. Here's 9 and 5, 14 hours. So this is the place where he can beat the total. So that becomes 6 and 10. Oh, 6 and 10, 16. What was this? 9 and 5, 14. Did I go too high? Maybe. Let me see. I think I chose the wrong one. It should be this one, I think. 6 and 10 makes 16. And this one is 9 and 5, which makes 14. It should be this point. I put the wrong one here. This is the solution. 9 and 5. 9 hours spent on the Saturday activity, 5 hours on the Sunday activity. Awesome.